So hello dear students, today we will start a new topic of chemistry called thermodynamics, and we will specify on reaction profiles because these are the foundations of our new chemical course related to the energy. So when we talk about the energy, we know that energy can either be absorbed or released. So absorption of chemical energy is related to the enthalpy change and can be labeled as plus delta H. So the reaction that involve absorption of energy called endothermic. So the absorption of chemical energy related to the enthalpy change, and enthalpy change is the heat content of some reaction, and we'll talk about this special term further in the future lessons. So the release of energy involves the negative sign of enthalpy change. So the reaction itself can be called as exothermic. So endothermic reaction and exothermic reaction are both involved in the processes that are related to chemical energy. So today we will talk about the reaction profiles of especially of endothermic and exothermic processes. So actually, when we will discuss the reaction profiles, before the discussion we should consider the examples of both reaction types. So firstly, endothermic reactions that involve heat absorption, exactly. So the very common example is the melting of ice. So suppose that H2O in the solid form turns into H2O of liquid form. So actual melting of ice is also endothermic reaction. So when we discuss exothermic reaction, we can consider some reactions that we discovered at the beginning of chemistry courses. So those reactions are, for example, the burning of coal that produce heat and CO2 gas. And also there is one type of reaction that is always exothermic, is the reaction of neutralization. For example, reaction of sodium hydroxide and hydrochloric acid. This reaction produces us H2O and sodium chloride. So the first reaction of C plus O2 is the reaction of combustion. So this reaction is always negative as sign of enthalpy change, and second reaction of neutralization is also always negative. Now, after looking at the examples of both reaction types, we can consider actual reaction profiles of 4 endothermic and exothermic processes. So let's draw the graph that has an ordinate axis of chemical energy I'll write this axis as E, and so the reaction will transfer the chemical energy from reactants, from this line, to the product's energy at line that was labeled as P. So R is the line of reactants energy, P is the line of products energy. So we can consider the two lines from this graph. So let's say that this green line from the reaction, from reactants energy to the higher slope, this green line represents activation energy of the endothermic reaction. So also this distance between the reactants to products line will be the total energy change in energy. So this is a reaction profile for endothermic reaction. For exothermic reaction, we do the same process, but with some differences. So we'll have the exact same ordinate axis of chemical energy, and so the reactant's energy will be higher than the product's energy. Where you now can see that the reactant's energy of endothermic process was significantly lower than the product's line, but in the exothermic reaction, the reactant's energy is higher in value, larger in value. So the actual process of exothermic reaction involves the transfer of energy to release. So we can say that the reactant's energy will be higher than the product's energy. So we now can indicate the two slopes of two lines that will indicate the process. The first line with green color will show us again the activation energy for exothermic reaction, and the red line will show us the energy transfer, energy change, or amount of released energy. So these two reaction profiles are really important in the course of chemistry